were calm from an eruptive standpoint. Bright active regions are not flaring on the south, but we do have a solid coronal hole coming through on the north. If its solar wind enhancement hits our heliographic latitude, it will be in about 2 or 3 days, and it will be quite obvious. The plasma speed of the solar wind, purple, is under 300 kilometers per second, and that's very weak solar wind. Phi angle motion up top in blue is likely the sector boundary preceding that stream, so there is in fact a good chance of us seeing the enhanced coronal hole solar wind in a few days. There actually was a modest eruption on the sun yesterday morning. This CME seen going off the western limb of Soho, Lascaux, went off the far side of the sun and is indeed headed about 120 degrees away from Earth's trajectory in the solar system. Quick look at Yasa hitting Fiji here. It was about as expected, with landslides, localized flooding, pretty bad wind damage. On the other side of weather and the world, the story was the blizzard. There are a lot of records broken by this snowstorm, and it's not just the snow, but for the cold as well. La Nina conditions set to pull these shenanigans over Europe and the upper Midwest as the winter marches on in the northern hemisphere. Let's go to a new animation from the AGU showing ways that clouds can appear and generating them via Kelvin-Helmholtz processes. But if I had said these were cosmic filaments and gas clouds, I probably could have fooled some of you. Of course, the similarity is the point. But I'm not sure what the point was of pointing the cameras here at the south pole of Mars, but I'm glad they did, and so are they. They were not expecting to see a giant arms-up human figure in the geology with full halo and aura around the head, and a giant heart next to it. That Mars is a good one. Up next, we continue with little needed but an eye for pretty colors. As technology improves, they believe they can look ever deeper into cosmic arenas, but they always seem to be surprised at what they find. Here, they were very surprised when they looked inside a massive galaxy, bright as can be, where all their math told them they would find a supermassive black hole, but they see no evidence whatsoever, just a halo of plasma glowing in X-rays. They expected a cosmic jet, core nucleus, torus, something, but there's nothing. Up next, we've got a cosmic web study on Abel clusters, and here is where the eye candy begins to blend into the science breakers. New modeling results based on observations of Abel clusters 3391 and 3395 show amazing matchups with certain simulations, with a few not-so-trivial caveats to the new record-long filament in space. It's a galaxy connector at 50 million light-years long, but its nature as a plasmic filament in space is only half the story. They have a particular simulation and observation comparison here, with the sim on the left, reality on the right. Not bad, for sure, but the obvious differences don't seem too obvious to the scientists. The extra clusters peppered all around, and more importantly, the extra bulk halo mass of normal matter around the galaxy clusters implies that plasma halo science can be seen from macro scale. On the left, the big red bubbles are missing, and similar halo features, and that's because it's supposed to be dark matter, but there's a reason why they can't find it in space or in a lab. This is what happens when you declare universal rules with only about 4% of the technology required to do so. Now lastly, on the science front, we're going back to the super lightning from this past summer. It was probably the biggest ongoing story. The rampageous Earth discharge events upward at rates never before recorded. Well, it turns out, scientists noticed lightning anomalies at the same time in the Arctic. Folks, of course this chart doesn't come with a great explanation other than, look, more lightning in the Arctic. But what you need to realize is, it's not like this line goes back down to zero if you go to 1990 or 1900 or ever. There was a low, steady amount of Arctic lightning that was not really changing until just this last decade. Folks, the peak years among the rise here are the powerful polar vortex years, not the hottest ones. They were the ozone destruction years, and it's a nod to the hundreds of papers on space energy-forced lightning and the talks given this month at the AGU fall meeting on atmospheric electricity. Sadly, it's also another sign that Earth's magnetic field is dropping its guard. It's been 12,000 years of powerful protection, but with her excursion to slumber en route and underway already,